hopefully you can hear me and see me this morning. Slightly, well, 1 minute overdue, but yeah, I just wanted to make sure everything was sorted before I got started. So what I'm going to do today is I'm going to finish off the final questions and probably the hardest questions from November 2023 2H paper. Okay, that's the plan for today. And then what I will do after that is I will, on a new stream, I will start going through the questions on the 2024 summer paper. Okay, so we got up to yesterday, or I got up to rather, this question, which was question 21. So now moving on to question 22, which is quite a hard vectors problem. And again, if you're somebody, sorry, I'm looking for my pen. Seems to have been moved. Which basically, like I was saying there, somebody's moved my pen. I might have to, this is going to make things trickier. Is one of the harder questions, but if you're someone from my school, then you won't have been taught, you won't have done vectors yet. Right. One second. Let me just try and find where this pen has gone. There it is, got it. Right, okay, so we've got on here OA is equal to 3A, OB is equal to 4B, B to C is 2A minus 2B. So the first bit isn't too hard. It's finding the vector O to C, which is just going to be basically how we get from O to C and what vectors we use. So we need to go from here to here. And you can't go straight there, you need to go around. So I would go 4B and then 2A minus 2B. So I'd have to do 4A plus 2A minus 2B. Okay, and I can underline those vectors. I'm going to do that because it's going to make things easier, especially for in a second when we get to part B. So simplifying that, we've got 6A minus 2B. Okay. Right, so the next thing that we need to do from there is find the vector AB in terms of A and B. So that is from, and I'll rub out the other lines I've done. We need to get from here to here. So we're going to need to go down this way. Now we're going in the opposite direction to that arrow, which means it's going to be negative of that vector. And then we're going to go along this way. So it's going to be minus 3A plus 4B. And we can't simplify that because there's no more A's and B's. So that is just our answer. Minus 3A plus 4B. Okay. Right. Now, from here, and I am going to have to keep scrolling up and down, unfortunately. But from here, going on to the next part, it says point P lies on AB and on OC. Okay, so let's go back up the diagram. Point P lies on AB and on OC. So that's this point here, which is marked as P. Okay, using a vector method, find the ratio A to P to B. So what we need to do is essentially we need to split up this line into a fraction of the full line. Okay, we need to get a fraction for AP of the full line and a fraction PB again of the full line. Now, if we just work out one of those fractions, we can work out the other fraction because they should add up to 1, because we've got 1 whole of AB. So, for instance, if AP was 2/3 of AB, then PB would be 1/3. Okay, so what we've got though, and this is basically the key bit to solving these questions, is we know, because it says it in the question, that the point P is some distance along the line AB. Okay, it's some fraction of the way along that line. But we also know it's some fraction of the way along the line OC. And so what we can do is we can introduce some variables because we know it's a fraction of the way along each. And then those vectors, with a little bit of minus 3A included as well, will be equal. So I'm going to write down now what I'm trying to say here. Hopefully it'll make a little bit more sense, but this is one of the trickiest questions that comes up on the IGCSE papers. Now, they have come up previously, they could come up again. And so as long as you've practiced them, it's the same method. You've just got to try and, you've got to understand. I say try and understand, obviously you're going to try. But you've got to understand what's happening and what you're doing. So I'm going to start off by saying a to p is a fraction of ab. Now we've already got ab, it's this bit. So we're going to use these, typically you use these letters called lambda and mu. Now, you could use them, you could use x and y. To make things easier, especially for someone who hasn't seen this before, I'm going to use x and y. So I'm going to do a multiple of AB, which would be AP, okay? So AP, I'm going to say is x lots of, so some fraction of AB, and AB is minus 3A plus 4B. So if we expand that and multiply those two terms by x, we get minus 3xa plus 4xb. Okay, now what we're going to do next is we're going to also do another way of a to p, but that's going to involve doing minus 3a and then plus a fraction of o to c. Okay, so AP is also... Okay, we're going to go from A to O, which is minus 3A, plus some fraction, we're going to call it Y, of O to C. And O to C we've already worked out is 6A minus 2B. So 6A minus 2B. Now, that is two different ways of getting from A to P. So I'm going to expand this again and simplify. So we've got minus 3A. Plus 6ya minus 2yb. And then what I'm going to do is I'm going to collect my a terms and I'm going to factorize. So I'm going to get this as minus 3 plus 6ya and then minus 2yb. What we're then going to do, and I'm going to use a highlighter here, is we're going to look at the a coefficients, so minus 3x and this minus 3 plus 6y, they have to be the same. And also, I'll choose a different color now, which hopefully is okay to see. Let's go with a blue. So we've got 4 plus 4x and minus 2y. So these things, because they're the numbers or coefficients in front of our b vector and our a vectors, they have to be equal. So choose a different colored pen here again. So what we get is minus 3x, so this is our a coefficients, is equal to minus 3 plus 6y. And we also get, and I'm just going to move this slightly to the left, we have also got, if we look at our b coefficients, 4x is equal to minus 2y. Okay, now from there, I am going to look at the right-hand side one because that's a little bit easier to deal with at first. I'm going to divide both sides here by minus 2. And what we're going to get is y is equal to minus 2x. And then I'm going to substitute that in for the y, okay? So I'm going to put that here. So I get minus 3x is equal to minus 3 plus 6 lots of minus 2x. And so what we're going to get here is minus 3, need to scroll down, x is equal to minus 3 minus 12x. I'm then going to add the 12x to both sides. That's going to give me 9x is equal to minus 3. And then divide by 9. Now, I seem to, somehow, I've gone wrong slightly with this one because, and this is, I've got x is minus a third. Now, that isn't going to make any sense because if I go and look at here, a to b, if I have minus a third of that vector, I'm going to be going in the opposite direction. So let me just read over this all and check again what I've done. So a to b, we got as minus 3a plus 4b. Okay, o to c was 4b, 2a minus 2b. So o to c, I've got 4b add minus 2b, I wrote that down as an A, that should have been a B, because we went along 4B and then add 2A minus 2B, so we get 2A plus 2B, and that feels a lot more right. That's just going to mean I'm just going to change things slightly down here, but a helpful tip is from there how to know that that's not correct. A minus scale factor is going to be going in the opposite direction. So I need to just change my OC down here now. So OC was this bit to 2A plus 2B. And then that would make more sense and hopefully it will work. 2A plus 2B. So we get here 2Y. Oh, oops. Green pen. Minus 3A plus 2. Change that highlighter back. There we go. So minus 3. Now I'm going to need to change some of the other stuff very quickly. So we've got 2Y. So 4x is equal to 2y. Got that bit. So then we just divide by 2 and not by minus 2. That looks more like it. Minus 3 plus 2y here. Okay, so 2 lots of 2x, which is going to change this bit to 4x. That looks more like it. You definitely know I'm doing this in real time now. So plus 3x, I would probably do now to both sides to cancel out my smallest amount of x's, and then this bit will slightly change. One other way you can check this as well is that these solutions should work in both equations, and so you can check because it's essentially simultaneous equation at the end that way as well. So I'm going to get 0 is equal to minus 3 plus 7x. Add the 3 to both sides, we get 3 is equal to 7x. Divide by 7 now on both sides, and you get 3/7 is equal to x. That looks more right because, well, it's positive at least, and it's a fraction less than 1. So what that means is at this point, if we go back up, we have got from A to P would be 3/7 of the AB vector, because remember that was AB. So going back to our diagram, this is 3/7 of the red line down here, okay, A to B, which means that this must be 4/7 of the distance along this line. And then you need to write your fractions as a ratio, and so to do that, you just use the top numbers, okay, use your numerator. So it'd be 3 to 4 would be A to P, P to B. Okay, so 3 to 4. Okay, right, hopefully that makes sense, even though there was a slight mistake in there that needed correcting. If you've got any questions, put them down in the comments, I can see them. So yeah, just let me know if there's any questions. Okay, next one. This is, well, I was going to say fairly typical question. It's not untypical. They like to include frustums, but they can make the questions in slightly different ways each time. But they do like to include frustums. Now, here, we are told the height of the cone is 15. That's the full cone. We're told the radius of the large cone is 6, as labelled on the diagram. The radius of the small cone is x, again, as labelled on the diagram. And then we're told the volume of the frustum. Now, the frustum is this bit, okay? It's basically a cone with the top part of the cone taken off. Okay, we're told that is 421/25 pi. Don't forget the pi. It says show clear algebraic working. Now, what we need to do here is we need to use a scale factor. And so what I would do, because basically the top part of that cone is going to be a similar 3D shape to the full large cone. So I'm going to do a quick sketch. And it is a sketch. I'm not an artist. So bear with me. This is the top part of that cone, the small cone that's been taken off, this bit. Okay. So I'm going to mark on what I know, and I'm going to look at corresponding lengths. So here, that has got a length of x. Now, I need to know how to get from this 6 to x and what I could times by, because then what I'm going to do is I'm going to use the full height to get the height of just that top bit. Because to work out the volume of a cone, we need to do a third times pi r squared h. That is a formula that is in the formula sheet at the front of the test. So to get from 6 to x, I need to divide by 6, and then I need to times by x. And so our scale factor to get from the bigger one to the smaller one is timesing by x over 6. That will divide by 6 and times by x. Now we're going to need to do the same with this 15. We're going to need to times by x over 6. Now, what that's going to do is it's going to divide the 15 by 6, which is 2.5 or 5 over 2, and then obviously times by x. So we get, and you can leave it as a fraction or as a decimal, 5 over 2x. That's the height there. What I'm going to do, just to make this a little bit clearer to see, is I'm just going to change this to a different colour. So let's make that red, let's say. Do the same with this one, just so you can see that that is the scale factor. Okay, now it says do it algebraically, so what we could write down in terms of algebra is we could write length scale factor is equal to x over 6. Okay, if you go from the big one to the small one. If you go from small one to the big one, it'd be the other way around, it'd be the reciprocal. Okay, I'm just going to change the sign of that, because otherwise it's going to annoy me. Okay. Now, what we can then start doing is using the formula for volume of a cone, which I said a second ago. I'm going to write down again now. It's a third pi r squared h. So we're going to use that for both of them. We're going to work out the volume of the full cone, work out the volume of the small cone, subtract them. That answer will be equal to 4212 over 25 pi, and then we're going to solve it. So, volume of large cone. Is this also for O levels? When you say O levels, do you mean A levels? Or, because I think O levels were what GCSEs used to be called. So yeah, if you could just let me know in the comments, I will, I'll let you know. This typically won't come up very often at A levels, to be honest. A levels is more highly algebraic, and you won't have a similar shaped problem like this, usually at least anyway. Okay, so volume of large cone. Right, okay. I'm not 100% sure. Well, I don't know, to be honest, about GCSE Pakistan. I'd have to look into that. But if you've got things like cones on it, if you learn about volume, if you learn about surface area, then this is something that they could include. Okay, so quite often exam boards, GCSEs, they like to look at other exam boards, GCSEs, and not steal, but look at types of questions they do and maybe use similar types of questions, especially if there's something different from what usually happens or is usually on those papers. But yeah, it'll all depend whether this is part of the, not scheme of work, but it all depends if it's part of the course, essentially. If this is something you learn, then yes, it could be on the test. Right, so the volume of the large cone is going to be a third, I'll have to scroll down, a third times pi times 6 squared times the height, which is 15. Okay, and I'm going to put that into my calculator and get an answer. So 1/3 times pi times by 6 squared times by 15 is 180 pi. And then I'm going to do the volume of the small cone. So that's a third times pi, and the radius for the small cone is x. So that would be times x squared times by the height, which is 5 over 2x. We need to simplify that. Hopefully that's answered your question anyway, Abdul. Thank you for watching the stream, and thank you for, put the questions in the chat. So third times pi, and then we've got times 5 over 2 I'm going to put in the calculator, because the rest is going to have to be algebraic. So that is 5 over 6 pi, but I've got x squared times x, so that's x cubed pi. Now, if I subtract those two from each other, that has got to be equal to this. So 180 pi minus 5 over 6 x cubed pi, and that's equal to 4212 over 25 pi. What we can do from there, scroll down slightly, is we can cancel out the pi's. Because there's a pi involved in everything, you can divide everything by pi. Okay, so that will get cancelled out, as will this, as will this. What we've then got is 180 minus 5 over 6 x cubed, and that's equal to 4212 over 25. I then need to get my x cubed on one side and get this fraction, or the numerical part, all on the other side. So I'm going to add 5/6 x cubed to both sides, and I'm going to run out of space here a little bit. There's another page, that's good. I'll carry on this next page. So I'm going to, like I say, add 5/6 x cubed to both sides, so that's positive. So I'm going to get 180 equals 4212 over 25 plus 5 over 6 x cubed. I'm going to take away this fraction, so subtract 4212 over 25. And we're going to get 5 over 6, need to scroll down here slightly, x cubed on the right-hand side left over, and then 180 minus that fraction is 288 over 25. We're going to divide both sides now by 5 over 6. That's the word I was looking for earlier. Yes, the syllabus. I'll have a look in a second, but if you give it a quick Google search, you should be able to find it. Yeah, I'll have a look in a second. After I finish this test, and I've got one more question left, which hopefully shouldn't take too long, but that's quite highly algebraic. That's something which, if anyone's watching, would be relatively common on A-levels. I say relatively common, something they could ask you to do at A-level. But yeah, I'll have a look after I finish these two questions. And then what I'm planning to do, Abdul, is for some of my streams up until Thursday, I'm going to do any paper, any question. So if you put a paper or a question you want me to do in the chat, I will get that sorted and I'll go through that either in the same stream or the next one. So yeah, feel free to put in the chat any questions that you've got, you want explaining, going through, etc. Right, carrying on with this one. 288 over 28 divided by 5 over 6 gives me 432 over 35. That is equal to x cubed. Just checking I've done that right. Okay. Cube root 432 over 35. And that's going to give me a decimal answer, which is not what I remember, to be honest, when I did this before. So let me just double check my working out again. So this all looks right. 1 times 5 is 5, 3 times 2 is 6. Yeah, right. And then we've got 180 minus this 42. Let me double check that bit again. 4212 over 25 and 180 minus that. Divide that answer by 5 over 6. Yes, I don't know what's happened there when I've done that. Have I miscopied something down? I have. That's what I've done. Simple, careless error. That should have been 25 on the bottom. And then that makes this, when you divide by 5 over 6, 1728 over 125. Now, the other thing which made me question that was, I got a decimal answer. Now, I got a decimal answer, and I looked at the question, and it didn't say anything about rounding. If it doesn't say anything about rounding, and you're getting a decimal, double check what you're doing, because chances are it shouldn't be a decimal. Okay? Right, so we get to this point, we're going to cube root both sides, and then we should get a nice value for x. So, cube root, answer 12 over 5, which is an exact decimal. That's 2.4. Okay. Couple of tips there. Check what you're doing. Also, it's helpful to know what to look for as kind of not like tips, but kind of clues as to whether you should check your answer. Is that something that feels right? You know, have they asked you to round it? Is it something negative when it should be positive? Yes, this is EdXL. Yeah, IGCSE. Just responding to someone in the chat. Hello, whoever that is. Don't know who it is, but hello. Good morning on Sunday morning, 11:30. Right, last question on the paper. This one. Now, when you get algebraic fractions of any kind like this, what you need to do is you need to simplify. So factorize everything that you can. And so that might take a couple of steps. You might not be able to do it all straight away. And one thing which is useful is that you should know that some brackets should cancel. So there should be some on the top that are the same as some on the bottom. That can help you with factorizing. So if we look at this top bit here, first of all, I can factorize an x out of that. So I'm going to get x 45 x squared minus 80. I can actually factorize a number out of that as well. So I'll do that in a second. And then I hope, and I think I'm going to get a difference of 2 squares here. Probably should do. The bit at the bottom, I'm going to leave for the moment. I could explode the middle, but I think, like I say, there's going to be a bracket on the top, which will be the same as a bracket on the bottom. But if there isn't, we'll complete it. Explode the middle or split the middle. I might have said complete the square there. I didn't mean that. Okay, this next bit, I'm glad the algorithm's working. It has helped you. Right, the next bit here, I need to add these two fractions inside of the bracket. And so what I need to do is I need to have the same denominators to do that. And there's nothing I can multiply the denominators by to make them the same apart from each other. So I'm going to have to multiply this one, top and bottom, by x, and this one, top and bottom, by 3x minus 4. So we're going to get x over x brackets 3x minus 4 plus 3x minus 4 over x brackets 3x minus 4. Okay, and that's equal to what we had at the start. 4 brackets x plus 2 over 5x minus 8. Okay, we still need that bit because we do need to solve it in a second. Right. We can simplify a little bit more here. So these numbers here, I can divide both of these by 5. The first one's 9. The second one should be 16. So I'm going to get 5x outside, and then I'm going to get 9x squared, which is a squared term. It's 3x squared, minus 16. That's 4 squared. And then on the bottom, I've got a feeling I am going to need to probably explode the middle, split the middle here. I have got a video on my channel as well about exploding the middle if you're not sure, not comfortable with that. So essentially what I need is two numbers, not 3, 2 numbers that multiply to give minus 12. I'll just do some factor pairs up here and add to give 1. Now I know this because, well, I know what the numbers are going to be pretty quickly because I've done a lot of these, but it's going to be 4 and minus 3. Okay, I need factor pairs of minus 12, which is the first number here, and the last number times together. I need those numbers times together. I need a factor of that that's going to add to give me the middle term, which is 1. Okay. Thank you, Percy. Yes, I was. Yes, exactly. Also, Aggie, you're right. It is 3 and 4. One's got to be positive, one's got to be negative. Exactly. So it's going to be 3x squared plus 4x minus 3x, because that gives me the 1x minus 4. And then we need to factorize this and this, and that'll be the next step in a second. And with this bracket here, I can add the numerators now because those denominators are the same. So x add 3x is 4x minus 4 over x brackets 3x minus 4 That's equal to 4 brackets x plus 2 over 5x minus 8. So we're getting there. Next bit is factorising this and factorising the top. Let's do the top first. That makes sense. So scroll down a little bit more. 5x, and then this is a difference of 2 squares. So I'm going to square root 9x squared, which is 3x, and then square root 16, which is 4. So we're going to get 3x plus 4 and 3x minus 4. Now remember what I said at the start, a bracket on the top, which should be the same as a bracket on the bottom, and over here we've got that 3x minus 4 on the bottom. And then we're going to factorise the denominator of this fraction. So 3x squared plus 4x, the first two terms, going to factorise that. Can only take an x out of that, so I'm going to get 3 and then x plus 4. And then the last bit, I can only really take in minus 1 out of that because I've got to have the same bracket here. So minus 1, 3x plus 4. Okay, minus 1 times 3x is minus 3x, minus 1 times 4 is minus 4. Then in a second, we will factorise this x minus 1 out to the front. And then we're going to times by. I can factorise this numerator, so that would be 4, and then it's going to be x minus 1. Okay, that's good, because we've got an x minus 1 in a second on the bottom here as well. And then we've got x, 3x minus 4. That's equal to this thing again, 4x plus 2. Now, I am going slightly slower through these problems. The reason for that is because I'm trying to explain them. So if I was doing this on a test myself, I would be going a little bit quicker. Because if you add up the 3 videos I've done on this, it'll come up to over 2 hours. Because of all the talking, the explaining, the level of detail I'm going into as well, which sometimes is not totally, well, necessary for the exam, all the exam marks. It's over necessary, really, to explain it, if that makes sense. Right, I digress. Carrying on. This numerator is sorted, so I can just write that out again. And then on the bottom, we're going to factorise out this bracket, 3x plus 4. And so if we take that out of both of these two terms here, we're going to get left with the x minus 1 by itself. So 3x plus 4 is in both terms. What we're left with then is x minus 1. It probably will be to you, Percy. And this is one of the hardest questions on the IGCSE paper. So yeah, it probably will be confusing. You're not in 5th year, so it will be confusing. It's one of the hardest questions anyway. And actually, I was going to mention this at some point. I was looking at the grade boundaries for the IGCSE higher paper this morning. Last year, you needed 86% for a 9, but actually the average across about the last 5-6 years is 75% for a grade 9. Okay, so it has gone up. It was quite high last year, but the average is about 75% across the last 6 years. Obviously, in that, you've got the years when COVID unfortunately happened, and so the grade boundaries were a lot lower that year and the couple of years afterwards. Right, carrying on. We have now got to multiply this next by this for x minus 1, and on the bottom, x brackets 3x minus 4. We're nearly done. 4 brackets x plus 2 over 5x minus 8. We need to make it on the left-hand side of this equals one fraction before we start solving, really. Right, what I can do actually, before I do the next line, is that this will cancel with this, so that's gone. And then I am going to multiply these fractions here. So, I'm going to get 5x, 3x plus 4 is gone, 3x minus 4. And then I've got this 4 here, which I should have times by the 5, so I'm just going to change that. 5 times 4 is 20. And then we've got x minus 1 on the top here. On the bottom, we have got x minus 1 from here, and then we've got x, 3x minus 4. Okay, so at this point, we have everything is pretty much going to cancel. We are going to get 3x minus 4 is going to cancel. That will cancel with this. This will cancel with this. X will cancel with X. And so what we end up with is 20 is equal to 4 brackets X plus 2 over 5x minus 8. What I'm going to do now is times by the denominator. So I get 20 times 5x, which is going to be 100x. 20 times minus 8. Should be able to do it in my head. I'm going to use a calculator just to be sure. So minus 160. That's equal to 4 lots of x plus 2. Divide both sides here by 4. And I'm going to get 25x minus 160 divided by 4 is 40. That's equal to x plus 2. Then I'm going to need to add the 40 to both sides. I am running out of space here very rapidly. 25x is equal to x plus 42. Take away the x from both sides, and I'm going to get 24x is equal to 42. Divide by 24 on both sides. We're going off the paper here. If you need more paper during the exam, just put your hand up and ask for some. And that gives 1.75 as the answer, which is the answer it should be, as far as I can recall. But one thing I am going to do is I'm going to check, and I'm going to show you how to check that that is right. Because if you can check it in the exam, number one, you know it's right. And then also that means you don't need to spend any more time checking it, going through your solution. Okay. So if we go back up to the original question here, all we need to do is put in our calculator everywhere we see an x, 1.75. Now you could just have that as your answer button and just use your answer button to put that in. Now we're going to do it for one side of the equals, and then we're going to do it for the other side of the equals, and we should get the same answer. If we do, we know we're right. Does it say round it? No, it doesn't. Good thing to check, because if it doesn't say round it and we get a not a whole number, but an exact number, so an exact decimal, then that will help us be more confident. But good point. Right, I'm going to plug that into the calculator. I'm going to set 1.75, press equals. That's now my answer button. Fraction, 4 times answer cubed, minus 80 times answer, divided by 3 times answer squared, plus answer minus 4. Times by bracket. So it should look exactly the same on your calculator. So see if I can show you. It's a bit hard because it's backwards, but it should look exactly the same in terms of brackets and everything. Fraction 1 over 3 times answer minus 4 times by fraction 1 over answer, close the bracket. And that equals, at the moment, and it's not a very nice looking thing, it doesn't have to be, minus 336 over 555. Now let's do it. We'll do the same thing to this side. So 1.75 equals, that's now my answer button. Fraction, 4 brackets, answer plus 2, close brackets, 5 times answer minus 8 is 20. Right. Well, that's a problem, because that means I have gone wrong somewhere slightly, which I wasn't expecting to. Let me just check I put it all in right the first time when I did that left-hand side. It's not gone as well as I wanted it to this morning. At the moment, at least, let me just double check everything. 3 times 1.75. I typed in 4 times, not 45 times, right. So do double check what you put in your calculator as well, because that could be a problem and go wrong, especially when it's as complicated as it is. Okay, right. That's giving me 20 over 3 now, which is not the same thing, because that gave me 20. This is now giving me 20 over 3. I'm going to check I put everything in right again, because that should be the same thing. 45 times 1.75 cubed minus 80 times 1.75. over 3 times 1.75 squared plus 1.75 minus 4. Okay. Times by 1 over 3 times 1.75 minus 4. I put times in the middle. I should have put add of those two things. Now it's 20. Right. Had to check my checking because it didn't work. That is the right answer. That is the solution. I thought it was, and exactly like Percy said in the comments as well, it should be an exact value what you would expect because there's no rounding involved. Right, what I'm going to do now is I am going to end this stream because that is the end of this paper, and I'm going to start the new stream, and I'm going to go through the start of the 2024 summer paper. If there are any questions that you want me to go through from any paper, GCSE ideally, but any paper, put it in the comments, put it in the chat, and I will do that at some point before Thursday. I will let you know because I'll put it in the stream, a title, any question, any paper. Okay, so it should be pretty obvious which one that is. But yeah, put it in the chat. Right, I'll say goodbye, and if you want to join, I'll be on the other stream in a minute, really, not very long. All right, see you there. If not, have a good day. Bye-bye.